Hi guys, let's start the last exercise of this chapter, factorization. Basically a revision exercise, no new concepts. So let's directly get into the questions. So we'll start with question number 1. I notice that the first three terms will make x plus 1 upon 2x whole square, and these two terms have 7 common. So this is nothing but x plus 1 upon 2x the whole square, and if I take 7 common, this is x x plus 1 upon 2x. I have taken negative 7 common. In case you don't understand this, let me write what this would be. This would be x square plus 1 upon 4x square plus 2 multiplied with x multiplied with 1 upon 2x. X and x gets cancelled, 2 and 2 gets cancelled. We are left with only 1. So this is basically the first three terms. So now between this term and this term, x plus 1 upon 2x is common. So I would take that common. What remains from the first term is x plus 1 upon 2x. What remains from the second term is minus 7. So this is equal to x squared plus 1 upon 4x squared plus 1 minus 7x minus 7 upon 2x. That's the final answer. Good, let's look at the next question. Next question is x squared plus a squared plus 1 upon a multiplied with x plus 1. I notice nothing common here. So let me just uh, break this numerator and denominator and see what do we get. So this is x square plus a square x upon a plus x upon a plus 1. So this is x square plus ax plus x upon a plus 1. I notice that the first two terms have x in common, but these two terms have nothing in common. So maybe I could write 1 as a upon a. So let's just write that. So this is x times x plus a, and instead of 1, let me write a upon a. Why am I doing that? I'm doing that so that if I need to take out something common. So I could take out 1 upon a common. Let's see how it helps us. This is x times x plus a plus 1 upon a. If I take common, what remains from the first term is x. What remains from the second term is a. Right? Now x plus a is common in both these terms. So if I take x plus a common, what I get from the first term is x. What I get from the second term is 1 upon a. So that's the factorization of x squared plus a squared plus 1 upon a times x plus 1. So that's our final answer. Let's look at the next question. The next question that we do is question number 5. Question number 5 says 4x to the power 4 plus 9y to the power 4 plus 11x square y square. So let's see if I can figure out what to do with this. Maybe I could, this obviously looks like 2x square the whole square plus this looks like 3y square the whole square. So if I were to make it 2x square plus 3y square the whole square, I would need plus 2 into 3, 6 into 2. So plus 12 x square y square. But I only have 11 x square y square, which means I will have to subtract 1 x square y square, which means all I have done is added x square y square and subtracted x square y square. Why I have done that? Because this will help me get first term whole square minus second term whole square, and the first term now would be 2x square plus 3y square the whole square. Yes, so the first three terms basically are 2x square plus 3y square whole square, and the second term now is xy the whole square. So this is of the form a square minus b square, which means a plus b multiplied with a minus b. In this case, a is 2x square plus 3y square and b is xy. So that's our final answer. You would write it as this is equal to 4x to the power 4, 9y to the power 4 plus 11x square y square. So again, this required us to add and subtract x square y square on our own. Next one, question number 8. It says 2a minus 3 whole square, 2 times 2a minus 3, a minus 1, a minus 1 the whole square. So let 2a minus 3 is equal to x and a minus 1 is equal to y. So what equation we are left with is x square minus 2x y plus y square. Oh, that's very simple. So what we now are left with is x minus y the whole square. Now substituting x is equal to 2a minus 3 and y is equal to a minus 1. So that's our answer, 2a minus 3 minus a minus 1 the whole square. Let's open the bracket inside. So this is 2a minus 3 minus a plus 1 the whole square. This is 2a minus a, that's a, negative 3 plus 1, that's negative 2 whole square. And this is equal to 2a minus 3 the whole square minus 2 times 2a minus 3 multiplied with a minus 1 plus a minus 1 the whole square. So that's our final answer. This is how it needs to be represented. Next one, the next question that we are doing is question number 10. So question number 10 says a square minus a multiplied with 4a square minus a or minus 4a minus 5 minus 6. I noticed that the first term has two a square minus a. If I take 4 common from here, I would be left with 4 times a square minus a. Let's go ahead and do that correction first. So not correction, taking common first. So if I take 4 common, what I am left with is a square minus a minus 5 minus 6. So let a square minus a is equal to x. So what we have is x times 4x minus 5 minus 6. Let's open the bracket. So this is 4x square minus 5x minus 6. Let's see if I can split the middle term to factorize this. I need to find factors of negative 6 into 4, which is negative 24, the sum of which would be negative 5. So 24 would be 8 into 3. Yes, that's correct. So negative 8 into 3. So that's how I can break up negative 5. So 4x square minus 8x plus 3x minus 6. Grouping it the way I have underlined, we have 4x times x minus 2 plus 3 times x minus 2, which means x minus 2 times 4x plus 3. Now x is a variable which we've introduced on our own. So let's resubstitute the value of x as equal to a square minus a. So the first one becomes a square minus a minus 2 and the second one becomes 4a square 4 times a square minus a plus 3. So this is a square minus a minus 2 and this is 4a square minus 4a plus 3. Now this is where usually students end up making an error, which is they leave the answer here. But notice that we still have a quadratic expression and we should check whether this can be factorized any further. So if you leave your answer here, you may not get your full marks because maybe this is factorizable further. I hope you remember, if b square minus 4ac is a perfect square, then the expression, which is quadratic expression, is factorizable, right? So we can try the formula or we can go ahead and check it. So in this case, I need to find factors of negative 2, the sum of which is negative 1. Now that should be simple. So this is a square minus 2a plus a minus 2. In this case, I need to find factors of 12, the sum of which is negative 4. So factors of 12, the sum of which is negative 4. So that would be 1 into 12, not possible, 2 into 6 or negative 2 into negative 6. None of them work. 3 into 4. I am unable to figure out the factors. Let's also check the formula. So in this case, b square would be negative 4 square minus 4 multiplied with 4 multiplied with 3. That's 16 minus 48, which is negative 32. No, this is not a perfect square, which means the second term in what we've got till now is non-factorizable. So I would leave it as is, 4a square minus 4a plus 3. Now grouping it the way I've underlined, we get a times a minus 2 plus 1 times a minus 2. That's our first big bracket. And here we have 4a square minus 4a plus 3. So this becomes a minus 2 times a plus 1 multiplied with 4a square minus 4a plus 3. And this is equal to a square minus a multiplied with 4a square minus 4a minus 5 minus 6. So that's the way to represent our final answer. Done. Let's look at the next question. The next one that we are doing is question number 12. It says 5a square minus b square minus 4ab plus 7a minus 7b. I notice that these two terms, if I take out 7 common, I should be able to get something. Maybe I should try and split the middle term here. So let's write it as the middle term first. So this is 5a square minus 4ab minus b square. And here let me take 7 common. We are left with a minus b. So here I need to find factors of negative 5, the sum of which would be negative 4. So negative 5 into 1, yeah, that should be fine. So 5a square minus 5ab plus ab minus b square plus 7 times a minus b. Let's group it the way I've underlined. All I've done is I've broken negative 4ab into negative 5ab plus ab. What's common between the first two terms is 5a. What I get is a minus b. What's common between these two terms is b. What is left is a minus b plus 7 times a minus b. I notice that a minus b is common in all these three terms. So let's take a minus b common for all these three terms. And what we get from the first term is 5a. What we get from the second term is plus b. What we get from the third term is plus 7. So that's our final answer, which is equal to 5a square minus b square minus 4ab plus 7a minus 7b. So yeah, that's about it. Nothing else remaining from this question. Let's move on to the next one. The next one we have is question number 14. I hope you are enjoying the video. If you have any questions or queries, please feel free to write into me. So question 14, 2x minus 3y. I notice that this can also be converted into 2x minus 3y if I take 4 common. So let's just take 4 common first. So this is 4 times 2x minus 3y the whole square. If I take 4 common, what I am left with is in this term 2x and here minus 3y minus 3. So let 2x minus 3y is equal to a. So our equation or other expression changes to 4a square minus 4a minus 3. Now this is a quadratic expression. I need to find factors of negative 12, the sum of which is negative 4. Yeah, so that's 6 and 2. Yeah, so negative 6 and positive 2. So 4a square minus 6a plus 2a minus 3. All I have done is I have broken negative 4 into negative 6 plus 2. Now grouping it the way I am underlined, what we get is 2a times 2a minus 3 plus 1 times 2a minus 3. 2a minus 3 is common, so the answer would be 2a minus 3 times 2a plus 1. Right? Is that the final answer? No, that's not the final answer because a is a variable that we've introduced on our own. So let's substitute the values. So 2 times 2x minus 3y minus 3. So that's the first bracket. And the second bracket would be 2 times 2x minus 3y plus 1. Let's open these brackets. So what we have is 4x minus 6y minus 3 multiplied with 4x minus 6y plus 1. And this is equal to 4 times 2x minus 3y the whole square minus 8x plus 12y minus 3. So that's the final answer, the way you should be representing it in your exam if you want complete full marks. Good, let's move on to the next one. The next one that we are doing is question number 16. So question number 16 says 9x square plus 3x minus 8y minus 64y square. I notice there is a 3x minus 8y. I notice this is 3x whole square and this is 8y whole square. So let's group it the way I have underlined, which would mean 9x square minus 64y square plus 3x minus 8y. The first two terms is basically a square minus b square. Let's write it in that form. 3x the whole square minus 8y the whole square plus 3x minus 8y. Now this can be written as a 3x plus 8y multiplied with 3x minus 8y. And these two terms can be written as 1 times 3x minus 8y. Between these two terms, we have 3x minus 8y common. So let's take 3x minus 8y common. What remains from the first term is 3x plus 8y. And what remains from the second term is 1. So that's our final answer. You would represent it as equal to the question. Good. Let's move on to the next one. The next one that we do is question number 17. Question number 17 says 2 root 3 x square plus x minus 5 root 3. Let's see if we can factorize it by splitting the middle term. So I need to find factors of 2 root 3 multiplied with negative 5 root 3, which is negative 5 into 2, 10, 10 into 3, 30. So I need to find factors of negative 30, the sum of which is plus 1, which means plus 6 multiplied with negative 5. That'll give me negative 30, and if I add them, I will get plus 1. Perfect. So 2 root 3x square plus 6x minus 5x minus 5 root 3. Yes, all I have done is I have broken x into 6x minus 5x. Now grouping it the way I have underlined, what's common between 2 root 3x square and 6x? Yes, the 2 root 3x is common. So this remains x. And what do I need to multiply with 2 root 3 to give me 6? Yes, I need to multiply it with root 3. So this is x plus root 3. Common between negative 5x and negative 5 root 3? Negative 5 is common. What remains is x plus root 3. Now between these two terms, x plus root 3 is common. So taking x plus root 3 common, what remains from the first term is 2 root 3x. What remains from the second term is negative 5. So that's our final answer. This is equal to 2 root 3x square plus x minus 5 root 3. Right, so that's how you would represent your final answer. Perfect. Let's move on to the last question that we'll solve from this exercise. That's last two rather. So let's look at question number 20, part 2. Question 20, part 2 says 67.8 square minus 32.2 square. So this is of the form x square minus y square, which means this can be written as 67.8 plus 32.2 multiplied with 67.8 minus 32.2. So let's add them. 67.8 plus 32.2, that's 100. And if I subtract, this is 8 minus 2, 6. 7 minus 2 is 5. 6 minus 3, that's 3. So this is 35.6. So the value is 3560. So that's our answer. This is equal to 3560. Last question of this exercise and the chapter. That's question number 20, part 4. Again, this is of the form x square minus y square, which means this can be written as 18.5 plus 6.5 multiplied with 18.5 minus 6.5. In the denominator, we have 18.5 plus 6.5. I notice 18.5 plus 6.5 gets cancelled in the numerator and denominator. So this is 18.5 minus 6.5, which is equal to 12. So this final answer is 12. Perfect. That brings me to an end of this video and the exercise and the chapter. Let me mark some homework questions for you. Question number 2, question number 4, question number 6, question number 9, question number 11, question number 13, question number 15, question number 18, question number 19, and question number 20, part 3. I hope you like the video, and I also hope you've been watching the homework question videos as well. If you have any queries, feel free to write into me. Take care. Bye bye. I'll see you with the next video.